talking about linear and quadratics. Part 1 was the linear piece. Part 2 is the quadratic piece. So we're going to be, really it's kind of an Algebra 2 review of a lot to do with quadratics. How we are graphing them and how we can rewrite equations and whatnot. But all related to the graphs. So, starting off here, quadratic functions and their graphs. So all parabolas based on y equals x squared. In this first set, we're looking at graphs that are in a form, not standard form, but usually vertex form, where we can basically look at how do we transform this graph. How do we take our basic parabola and transform it for this equation? So the directions here in example 5 ask us to describe how to transform the graph of f of x equals x squared into the graph of the given function, and then sketch the graph. Notice it says by hand. In other words, not just plug it into the calculator. Okay? So, I'm trying to think, did we have that? We had a transformation chart back in chapter 1 if you need to pull it back out. But g of x equals negative 1/2 x squared plus 3. What are the pieces you see here that are going to affect my graph? A reflection, yes? There's a negative out in front, which is a reflection. Reflection across which axis? Which one? X-axis, okay? So a negative is going to reflect it across the x-axis. What else? Okay. The plus 3 is going to translate my graph up 3 units. And?
Vertical compression.
Okay. The 1/2 is a vertical compression or a vertical shrink. I don't remember which we're using in this book versus last year.
I think we use shrink.
But here's the deal. What did I say from the beginning? Vertical shrink, vertical compression. I don't care which you are. Based on the fact that in my notes I have a vertical shrink, I'm guessing this pre-calc book uses vertical shrink. So, I'm going to write these out. There's a vertical shrink. By a factor of 1/2. There is a reflection across the x-axis, and a translation, excuse me, what do we say? Up 3 units. Okay. So, now, our job is to sketch this by hand. What do you know? We have our quadratic, yes? We have our basic U shape. What are we going to have to do with it? We're going to move it up 3. What else do we have to do?
You gotta make different y points.
Okay, we have to make different y points and?
Make them negative.
Make them negative, reflect them. Okay, so officially in terms of order, we really should do the vertical shrink first. So change your y values. Shrink them by 1/2. Then reflect it across the x-axis, so it's now upside down. And then move it up 3. Okay, now, when he talks about changing our y values, do you remember when I taught this in Algebra 2, for a basic y equals x squared, I always said think about 0, 0 is the vertex, 1, 1, 2, 4. The first set of points go over 1, up 1. The second set of points go over 2, up 4. Is that stuck with you, I hope? Okay, we did that a bunch. So now, we need to do y equals 1/2 x squared, which means we're going to do half, but what changes? Only the y values. It's a vertical shrink. My vertical values are y, so I'm shrinking them by 1/2. Remember, 0, 0 is representation of the vertex. So if 1, 1, instead of going over 1, up or down 1, it's now going to be over 1 and 1/2. Instead of 2, 4, it's going to be 2, 2. Excuse me. And that is all just, if you need to write yourself a note, what did we do? We multiplied by 1/2. Okay. Okay. I think we have the information we need to graph there. So let's see. I have 4 tick marks on each line. Really, I think 3 tick marks would work.
It would.
Let's go 3 tick marks. This graph is not very big. And at pre-calc level, I'm kind of going with, you see this all coming together, right? So I'm not going to go, when I first teach it in algebra, I kind of go step by step, right? I'm not doing that here. We're just going to go for it. So we shrunk it. We changed our y values. We're going to flip it upside down, and we're going to move it up 3. So where's my vertex at?
0, 3.
There's my vertex, yes? Normally, my first step points are over 1, up or down 1. This time we're going to go over 1 and down.
Half.
And we're only going to go down 1/2. And this is a sketch, so we're not looking for perfection. But you can ballpark that that's not down a whole 1. And then my next set of points?
Over 2, down 2.
Yeah, normally be over 2, down 4. But we shrunk it in half. So we're going to go from the vertex over 2, down 2. Over 2, down 2. And? Ready to connect the dots?
Sure. Line is nowhere.
Okay. It is a shrink, so this should be, when you shrink something, we're forcing it down, which in the process makes it appear wider. Okay? Again, it's a sketch by hand. So, not perfect, but if you were to graph this via calculator now, it should match up. Okay, questions there? Okay. Let's look at B. H of x equals 3 times x plus 2 squared minus 1. So what pieces do we have?
Could be a stretch. Stretch by a factor of 3.
Okay, the 3 out front. Vertical stretch by a factor of 3. What else?
Go left 2.
Plus 2 inside the parentheses with the x. Anytime it's in with the x, it's left or right, opposite sign. So plus 2 takes us left 2. And minus 1 takes us down 1.
That's my main.
Okay, so I'm going to take a moment, write this all out. Vertical stretch. By a factor of 3. Translation. Left 2 units and down 1 unit. Okay. Okay.
Sounds good to me.
Let's see. As we think about this, we already talked about our y equals x squared. My basic parabola points are over 1, up 1, over 2, up 4. What about y equals x, or 3x squared now?
Now we're just gonna do multiply.
Three.
We're going to multiply our y values by 3. So 3 times 1
Three.
and 3 times 4.
What?
Yeah.
Hmm?
So x squared and multiplied by 2.
Oh, yeah,
Sorry.
sorry, yeah. I was looking at the 2. You said 4. I'm good now, yeah.
My x stays consistent because it's a vertical, not horizontal, right?
Yeah.
Okay. The catch here, we have to go up 12.
Yeah.
It is what it is. So
Do 6 lines by 2.
you could. I have mine. I just have mine going up all the way, but it's up to you. Notice my vertex is going what? Left 2 and down 1. So my graph is going to be more on that left side. So I technically do need 4 tick marks on the left, just because of where my vertex ends up. I need at least 1 tick mark down below. And I technically don't need 12 going up. I only need 11. Now, I'm not against you, for instance, counting by 2s, but you have to label it. Because if all of a sudden your graph doesn't go up high enough and you didn't show me that you counted by 2s, I don't know that. Okay. Okay. So my vertex went left 2, down 1. My first set of points that normally go over 1, up 1 are going over 1,
Up 3.
up 3. Which puts them 2 above the x-axis, if you will. My other set of points that normally go right 2, up 4 are going to go right 2,
Up 11.
up 12.
12.
But since I'm starting from 1 below the x-axis, I end up 11 above the x-axis. So you end up at 0, 11 and negative 4, 11. Okay. Something like that, yes?
Yeah.
Seems like you guys kind of remembered your algebra too. Definitely felt like it.
I feel like this has been, I don't know, like it always comes back.
It does, doesn't
And
it?
it feels like we didn't do anything different than we did last time.
Well, from my view, I'll say you guys definitely appeared much more okay with what I was doing.
Yeah.
You know,
But
it's there more. And algebra, because technically this does go all the way back to Algebra 1.
I was going to say,
Algebra 2 is when we really worked with the transformations. And this is more of a finishing touch, but I don't know. If anything, they just get a little bit more difficult is what happens. Okay. Notice those were in that vertex form. And we're going to continue to talk about vertex form because it gives us so much information. So, any quadratic function, f of x equals ax squared plus bx plus c. So that right there, that ax squared plus bx plus c, remember that is quadratic, or standard form of a quadratic. As long as a is not 0, can be written in vertex form. So right there, f of x equals a times x minus h squared plus k. This is your vertex form. And I call it the vertex, or it's the vertex form because the vertex is staring at you. Okay? So, a couple of points. The graph of f is a parabola with vertex of hk. So remember, h comes from in the parentheses because that's the left-right piece. You use the opposite sign. K comes from outside the parentheses. So there's your vertex. And an axis of symmetry of x equals h, which we know the axis of symmetry is always the first number in the vertex as well.
Yeah.
Okay. We can find h using the equation h equals negative b over 2a. Okay, this book uses h because that's what it stands for. You used the same exact formula last year. Okay, we can find h. When they're talking about finding h, we're talking about finding the axis of symmetry. That's what that is. That is finding the axis of symmetry. And so if you'd rather say x equals negative b over 2a, you can. And then they also say you can find k using c minus ah squared. Now, that's a new introduction for a pre-calc, and that is a way to find your k value. However, I also like to just plug, once you know your axis of symmetry, plug your y value, plug it into your equation to find your y value. And that's what they're talking about there. When it says k equals f of h, take your x, plug it into the equation. That's how you can find the second half, okay? And we'll practice. And then I would say this third bullet point is not information you need because you already know, I think. If a is greater than 0, so if our lead coefficient is greater than 0, my parabola opens up. If a is less than 0, parabola opens down, right?
Yeah.
Again, that's something I definitely tried to stress in Algebra 2. So,
It's negative, it's positive.
okay. Let's look at example 6. Use the standard form of this quadratic function to find the vertex and axis of symmetry of the graph of f of x equals 6x minus 3x squared minus 5, and rewrite the equation in vertex form. Okay. So, we're being asked to find the vertex and the axis of symmetry. Noticing right now it's standard form.
What? Did you say it is?
It's currently kind of standard form. We're going for vertex. What are you going to say?
No, just go ahead. I'll
Okay.
figure it out in a second.
Where can I start here?
Plug it in. Plug your axis of symmetry.
Okay.
Yeah, that's what I was thinking.
Find our axis of symmetry.
But isn't a negative 3? Just kidding. Yeah, okay, that's what I was messing with.
And that's why I said go ahead, because I kind of hinted at, but I wanted you guys to point out, this is kind of standard form.
Yeah, that's what got me. That was
It's standard form in that it's those pieces, but it's not in the proper order for standard form. Standard form officially goes from highest exponent to lowest exponent. So if I rewrite this in official standard form, negative 3x squared plus 6x minus 5. So if you didn't catch that, you may have used the wrong ABCs, right? So what is A while I'm here?
negative 3.
What is B?
6.
And what is C?
5. Negative 5.
5 of the negative variety.
That's right.
Okay. So in order to find my axis of symmetry, they use h equals negative b over 2a. I'm going to use x equals negative b over 2a. What are you coming up with? Negative 6 over 2 times negative 3.
Negative 6 over negative 6.
Negative 6 over negative 6, which is 1. So we have an axis of symmetry, x equals 1. That can also be listed as h. Okay, that is your h value. Okay. After you find your axis of symmetry, what do you find next?
Your vertex.
Your vertex. What do I know about my vertex right now?
It's something 1. Or 1 something.
How about 1 something?
1 something, yeah. Yeah.
Okay.
Yes. About 1.
So right now, the axis of symmetry, we know, fills into the first number of the vertex. Okay? In other words, that is my h. Okay. How do you want to find the second half?
Honestly,
Okay. What have I always taught? I've always taught take the 1 and plug it into the equation, yes?
yeah.
So what I'm going to teach is take 1 and plug it into f. So I'm going to be doing negative 3 times 1 squared plus 6 times 1 minus 5.
I don't know. I was trying to math in my head. It did not go well.
Your mathing did
I
not
wasn't
math.
doing that math. I was trying to math the other.
I had a feeling. Okay. I'll talk about that in a moment. So, okay. What I generally tend to teach, and what you guys have seen in the past, is plug 1 in. You plug 1 in, we get negative 2. And what do we know about that negative 2?
Why?
It's your y value.
Okay.
It's also k. Okay? Now, let me touch on real quick. I think, Logan, you were trying to use the k equals c minus a h squared.
Yeah.
Okay, well, and I don't care if you guys use this. It's not my cup of tea, but I'll give it to you. So k, c, what was my c? Negative 5 minus a, so minus negative 3 times h squared. H we just found to be 1. So I'm going to do negative 5. 1 squared is just 1, right?
Yeah.
Times the negative 3 minus negative 3. So it really just ends up being plus 3. You multiplied.
Yeah. That's right.
Does it work?
Yeah, it does.
It does.
I was there. I just multiplied.
Okay. Now, real quick, we got to finish this problem.
What?
Our job.
Oh, no, I got
Whoa. Rewrite the equation in vertex form. Vertex form is f of x equals a times x minus h squared plus k. I say we've got to finish the problem because we just have to write the answer. Okay. F of x equals
negative 3.
a. We didn't find a, did we? But it was given, yes. Negative 3. X minus h.
1.
X minus 1, quantity squared, plus k.
Negative 2
Minus 2. Okay. So we found an axis. We found a vertex. And then we wrote them in vertex form. Realize, don't forget to put your A in vertex form. We didn't have to work to do it. A was given. Okay. We will continue tomorrow. We will review completing the square. I'm sure a favorite topic you missed so much.
No, actually, I did not miss it, so can we not do that?
We will be doing completing the square tomorrow, and you should have some work time tomorrow.